Day 5 of 75-day DSA and C++ challenge. And today I'm going to show you a pattern that turns a 200x slowdown into a non-issue. Picture this. You've got a vector of 100,000 integers, and your interviewer asks for 1,000 range sum queries. Nested loop? That's 10 billion operations. Prefix sums? 200,000. Same answer, 200 times faster. If you're still writing nested loops for range queries, you're leaving interview points and CPU cycles on the table. Let's fix that. A prefix sum is exactly what it sounds like. Given an array A, you build a second array P where P of I holds the sum of every element from A0 up through AI-1. That single O, N, pass is your one-time investment. After that, the sum of any range L to R becomes P of R plus 1 minus P of L. One subtraction. O1. The whole trick is pre-processing once and querying forever, and it shows up in dozens of competitive problems disguised under different names. Here's the construction. Declare std. Vectorant prefix of size n plus 1. Initialize prefix 0 to 0. Then loop. Prefix of I plus 1 equals prefix of I plus a of I. Or use std. Partial underscore sum from the numeric header, passing a dot begin, a dot end, and prefix dot begin plus 1. The plus 1 indexing matters. By making prefix 0 a sentinel 0, your range query L to R is just prefix of R plus 1 minus prefix of L, with no special case when L equals 0. Boundary bugs gone. Let me show you a concrete example. Array 2, 4, 1, 7, 3. Prefix becomes 0, 2, 6, 7, 14, 17. Want the sum from index 1 to 3, that's 4 plus 1 plus 7 equals 12. Look at prefix P of 4 minus P of 1 is 14 minus 2, which is 12. Done. No loop. Want index 0 to 4, the whole array? P of 5 minus P of 0 is 17 minus 0, 17. The sentinel 0 is doing real work here. Without it, you'd write an if statement for L equals 0 every single query. Now the performance story. I built a product sales analyzer over 1 million daily entries and ran 1 million random range queries. Naive nested loop version with std. Chrono measuring? Roughly 40 seconds on my machine. Prefix sum version, including the one-time partial underscore sum pass? Under 100 milliseconds. That's the 400x range. The cache loves prefix sums too. You're doing a single linear scan during pre-processing, then 2 random reads per query. Predictable memory access, branch predictor happy, vectorizer happy. 2 dimensions, same idea. For a grayscale image stored as std, vector of std, vector of int, build a 2D prefix table where P of ij holds the sum of the rectangle from 0, 0 to I minus 1j minus 1. The query for any subrectangle R1C1 to R2C2 uses inclusion-exclusion P of R2 plus 1C2 plus 1, minus P of R1C2 plus 1, minus P of R2 plus 1C1, plus P of R1C1. You subtract 2 rectangles and add back the corner you double subtracted. Constant time average brightness over any region of any image. The off-by-1 trap on the 2D version is brutal. Trace a 3x3 example by hand before you ship it. I always write out the 4-term formula with the plus 1 offsets explicit every single time. And keep your loops row major. std. Vector of vector means each row is its own allocation, so iterating column by column thrashes the cache. Outer loop rows, inner loop columns. Same algorithm, 10 times faster on real hardware. Now the dual, difference arrays. Paint the wall problem. You apply plus 1 to a range L R many times, then ask for the final coverage. Naive is O of n times q. Instead, std. Vectorant diff of size n plus 1, all zeros. For each operation, diff of L plus plus, diff of R plus 1 minus minus. After all operations, run std. Partial underscore sum and place on diff, and you've got the final array. That's prefix sums running in reverse. Same O of in scan, opposite direction. And the interview classic, LeetCode 560, subarray sum equals k. Walk the array maintaining a running prefix total. Use std, unordered underscore map, and int, counting how many times each prefix value has appeared. Initialize map of 0 equals 1 before the loop. For each element, check if current minus k is in the map and add its count. O of n, day 5 done. Prefix sums, 1 O of n investment, infinite O of 1 queries, and a pattern hiding inside half the array problems you'll ever see. Subscribe for day 6.